This is for Year 11 methods and involves finding general equations for particular quadratics given that you know some information. Generally there are two forms we can use for the quadratic. We can use y equals ax squared plus bx plus c, and that's when we have three coordinates, and that involves solving three simultaneous equations in terms of A, B and C, and then substituting back in and finding out the values of A, B and C. The second form is when you have the turning point and another point, and you can use the general form, which is the turning point form, A brackets x plus b squared plus c. In both situations you need three pieces of information. To solve a quadratic you need three pieces of information. Either three separate coordinates, or alternatively, the turning point gives you B and C, so the turning point actually provides two pieces of information, and then A can be solved by using the third piece of information that you're given. Okay, let's demonstrate that first form, which is y equals ax squared plus bx plus c. And I've got 3 points, -3, 5, 320 and 557. Okay, using this coordinate, I know that 5 will equal a times 3 squared plus b times -3 plus c. So 5 will equal 9a minus 3b plus c, and I'm going to call that equation number 1. Using this second coordinate and substituting 20 for y, 3 for x, so that's 9a, 3 for x, that's plus 3b plus c, I'm going to call that equation number 2. And this third coordinate is going to give me equation number 3. 57 will equal 25a plus 5b plus c. So I have my three equations, equation 1, equation 2, equation 3. I'm interested in solving for each of the pronumerals, so I need to fiddle with pairs of equations to eliminate. Now straight away I can see a -3b and a 3b. So I'm going to generate equation number 4, which will equal equation number 1 plus equation number 2. Equation 1 is 5 equals 9a minus 3b plus c, and equation 2 is 20 equals 9a plus 3b plus c. If I add those two together, I'm going to get 25 equals 18a plus 2c, and I'm going to call that equation number 4. I have an equation now in terms of a and c. I now need to get another equation in terms of a and c. So what I'd like to do is to work with equation number 3 and equation number 1, because I've got my minus on my 3b and a plus on 5b. Lowest common factor between those would be 15. So what I would like to do is to get this to 15, I times it by 3. So 3 times equation 3 plus 5 times equation 1 is going to be what I call equation 5. So 3 times 3. 3 50s is 150, 3 7s are 21, so 171 equals 375a plus 15b plus 3c. That's 3 lots of equation 3. 5 lots of equation 1. 5 5s are 25, 5 9s are 45, 5 3s are minus 15b, and 5 plus 5c. I'm going to add those two together. 6, 9, 196 equals 120a, the b's disappear, plus 8c. There's a common factor of 4 in each of these, 30a plus 2c. 4 goes into 19 4 times with 3 over. 4 goes into 36 9 times. So that's equation number 5. I now have equation 4 in terms of A and C, and equation 5 in terms of A and C. I can now use those to eliminate one of those perennials. I can see 2C and 2C. So what I'd like to do is to go equation number 5 minus equation number 4. And that should eliminate the C's. So equation 5 is 49 equals 30A plus 2C. Minus 25 equals minus 18A minus 2C. And I'm subtracting equation 4, so I multiplied them all by -1. 49 minus 25 is 24. 30 minus 18 is 12A. The C's disappear. A equals 24 on 12. A equals 2. Okay, so I've got one of the solutions. A equals 2. What I'd like to do is sub A equals 2 into equation number 4. And then that will give me what C equals. 25 equals 18 times 2 plus 2C. 25 minus 36 equals 2C. Minus 11 on 2 equals C. And now I need to find B. And the way I'm going to find B is to sub A and C into equation number 1. So 5 equals 9 times A, which is 9 times 2, minus 3 times B, plus minus 11 on 2. I'm going to multiply everything by 2. 10 equals 36 minus 6B minus 11. Minus 6B will equal 10 plus 11 minus 36. Minus 15 on minus 6 is equal to B. B equals 3 goes into that minus, no, positive 5 on 2. So I found A, I found B, and I found C. That means that y equals 2a squared plus 5 on 2x minus 11 on 2 is the general rule. The second method involves using the general turning point rule. If I have this parabola and the turning point is at 2, 3, then I know that y equals a x minus 2 squared plus 3. Using my transformation information, I know that that will be a -2 and that will be a positive 3. Parabolas are perfectly symmetrical. I know that this goes through the origin 0, 0. If that's a distance of 2, then that over there will be 4, 0. So I now know how I now have a second piece of information. I can put that into the equation, and that will tell me that 0 will equal a 4 minus 2 squared plus 3. 0 equals 4a plus 3. Minus 3 equals 4a. A equals minus 3/4. Could I have used this piece of information instead of using 4, 0? Absolutely. If you put in 0, 0, then this would become 0 equals a, 0 minus 2 squared plus 3, 0 equals 4a plus 3. Again, a is going to equal minus 3 on 4. So that gives me my general rule, which is y equals minus 3 on 4, x minus 2 squared plus 3. An equation in turning point form.